Hello everyone, welcome back. This is part 2 of Geography NCERT Class 11 Chapter 3 Interior of Earth. Before we begin, I strongly recommend you that if you haven't seen part 1 yet, please watch it first. You can find the video in the playlist. Now without any further delay, let's continue with part 2. So let's start with the structure of Earth. Before starting, let's quickly see a video to understand the structure. So now, as it is visible in this video, that there are 3 layers in the structure of Earth. Number 1 is crust, then there is mantle, and then there is core. Now let's start first with the crust part. So crust is nothing but it's just the outermost solid part of the Earth, and it is brittle in nature. Now what does brittle mean? Brittle means कि उसके बहुत ज़्यादा टुकड़े हो सकते हैं. मतलब क्रस्ट को छोटे छोटे पार्ट्स में बांटा जा सकता है एंड इट्स द आउटर मोस्ट सॉलिड पार्ट ऑफ अर्थ एज वी हैव सीन इन दिस वीडियो. लेट्स सी अ फर्दर वीडियो अपॉन द क्रस्ट. Yeah, so in this video you have seen two things, that there is oceanic crust and one there is continental crust. Let's read upon it further. So we have seen that crust is the outermost solid part of earth. It is brittle, मतलब इसे छोटे छोटे टुकड़ों में बांटा जा सकता है. The thickness of crust varies under the oceanic and continental areas. We have seen in the video that in oceanic areas the crust is seen to be less narrow and it is more wider in the continental area. So let's just understand it. So oceanic crust is thinner as compared to the continental crust. The mean thickness of oceanic crust is around 5 kilometers, whereas that of continental crust is around 30 kilometers. So you might just think that what is this oceanic crust? Ocean just consists of water. No, but that water is also standing upon some land, upon some crust. Here the water is filled and that is what ocean is. But what is the depth of this crust? That crust is just 5 kilometers. However, on the continents that is present, like for example this is Asia, we have a crust below it. It is like, let's say below Himalayas it is 70 kilometers. So that is the difference. The continental crust is thicker in areas of major mountain systems. It is as much as 70 kilometers thick in Himalayan region. So now we have seen that okay, what is crust? Crust is just the outermost solid part of earth and it is brittle in nature. There can be two types of crust. One is oceanic crust and one is continental crust. Continental crust is much wider, whereas oceanic crust is much thinner. Oceanic crust is below the oceans, continental crust is below the continents. And when we will see the formation of mountains such as Himalayas in Indian geography, we will see that okay, one crust has come over the another crust. That is what we will call as crustal thickening or crustal widening. We will understand it in the Indian geography part, but for now it is only important to understand that there can be two types of crust, oceanic crust and continental crust. Let's move forward. Let's move now to mantle. Before discussing mantle, let's see an animated video that okay, like how does mantle is seen. So in this video, you could have seen that okay, mantle is something from around Moho discontinuity. We'll see that what is Moho discontinuity in just now in 2 minutes. And you have also seen that okay, there is something like asthenosphere in this mantle and there is something like lower mantle. There is something like lithosphere. We'll see that what all are these parts. So let's study. So the portion of interior that is below the crust is called mantle. Okay, so this is for example crust. We'll take this portion. Alright, this is crust. Below crust comes mantle. and below mantle comes core. Alright, so the portion of interior which is below the crust is called mantle. And the continuity. Now what does discontinuity mean? Discontinuity is basically where we have understood that what are P waves and what are S waves. So where the P waves and S waves direction changes. That portion or that line is called discontinuity. There are various discontinuities present between like core and mantle, mantle and core, inner core and outer core, but these are not important for us to discuss. We only need to remember that what is Moho discontinuity. Moho discontinuity is present between the crust and mantle. So mantle is between Moho discontinuity, that is between this portion between crust and mantle, and it lies till the depth of 2900 kilometers. The uppermost portion of mantle is called a asthenosphere. The word astheno means weak. We have seen in the video that it is something like this jelly-like structure, which is asthenosphere. And the upper, so now think that this is asthenosphere, and this upper 400 kilometer part is called asthenosphere. It is like a weak or a jelly-like structure. Just remember, okay, how is jelly? It is neither solid nor liquid. This is how asthenosphere is present. So it is considered to be extended till 400 kilometers. It is the main source of magma that finds its way to the surface during volcanic eruption. So we'll understand volcano in the upcoming slide, but just now understand that, okay, now this is how volcano magma is coming out. But what is the source of it? It is mostly considered that from asthenosphere because it is jelly-like. It is not solid. This magma is coming out. Now one more definition or one more point that we have to understand is that we all have heard the name of lithosphere. But what is this lithosphere? We have to understand this. So the crust and the uppermost part of the mantle are called lithosphere. Alright, so now we consider that, okay, this is crust and this is just the uppermost mantle part. This all is called lithosphere. And in the upcoming chapter, we will study the lithospheric plates. This lithosphere is broken into different types of plates like Eurasian plates, Indo-Austrian plate, like this. The thickness ranges from 10 to 200 kilometers. The lower mantle extends beyond the asthenosphere and it is in a solid state. Alright, so now what we have understood about mantle is that this portion is what is called asthenosphere, okay, and this is in a jelly-like state. Beyond this, it is lower mantle and it is solid in state. So mantle has two types of state in it. Now we have understand what is crust. We have understood what is mantle. We have understand what is asthenosphere. Asthenosphere is nothing but it's just the uppermost part of mantle which is jelly-like in structure and it is the main source of magma which is coming out through volcanoes. And we have understand that what is lithosphere. It is the crust and the uppermost part of mantle. Now the next thing that we have to understand is basically core. Let's see a video to first understand. Alright, so what can we see in the video? We can see that, okay, this portion is basically the outer core and this solid part is the inner core. Now, what is the state of this outer core that you can see? It is like liquid. Fine. And it is solid. Now, the most basic question that can come is we have already seen in the sources of understanding the interior of Earth that, okay, temperature and pressure both increases while going deep inside the Earth. Now, at such a huge temperature, जब temperature बढ़ता है, तो for example, take पानी. Pani also converts from ice into water. So why is this inner core, the temperature should be the highest or the maximum here? How is it still in a solid state? It is because of pressure. When pressure increases, molecules come together. Now, let's see. This is something. If you compress, if you put a lot of pressure in it, the molecules which were like earlier like this, they will come like this, close. So when it reaches to this depth of inner core, the pressure overtakes temperature. Alright, here pressure is overtaking temperature. Thus it's in a solid state. However, in the outer core, it is temperature which takes over the pressure, and thus it is in a liquid state. Alright, is this thing clear? And this thing should be remembered. Right, let's study about core. So the core mantle boundary is located at a depth of 2900 kilometers. We have already seen in mantle that what is the extent of mantle? It is from Moho discontinuity to 2900 kilometer. The outer core is liquid while the inner core is solid. The core is made up of very heavy material, mostly which is constituted of nickel and iron. It is sometimes referred to as knife layer. Alright. So we have seen that when we have understood about the evolution of lithosphere, that okay, the most densest material have gone most inside the surface of Earth. And that is how differentiation has created lithosphere. Alright, so now what we have to remember is that very, very heavy materials like iron, nickel, these are all present in the core. Alright, and iron is Fe, the symbol is Fe, and nickel is Ni. That is why it is called knife layer. Understood? So that's all things that we have to remember about core. Right? Now, let's go further. Now, the next topic that we have to understand in detail is that what is a volcano. We have all seen the images of volcano, that it is something like a mountain and like hot magma, lava, gases, big boulders, बहुत सारे पत्थर, gases, carbon, sulfur, all these are coming out. We have all seen the videos, right? Now, but what is this volcano? What are the types of volcano? Now, when lava or magma is coming out, it must be solidifying at some place. So, various type of landforms must be found. So, this is what we have to understand in this part of video. Right, so let's start with first what is a volcano. Let's see a video to understand. You all are aware and you all have seen the image of a volcano, but let's just rewind our memory and see it once again. Right, so in this video you have seen that it is just a vent from which all of these material is coming out, and this is exactly what volcano is. It is nothing but it's just a vent or a opening, right? Let's study it. So volcano is a place, or it's a vent, or it's a opening from where gases, ashes, molten rock material, lava escape to the ground, right? So what does all come out from a volcano? It is gases come out, ashes come out, molten rock material come out, lava escape to the ground. So the mantle contains a weaker zone which is called asthenosphere. We have already seen that what is a asthenosphere. It is from this that the molten rock material find their way to the surface. We have seen that okay, asthenosphere is now like in a jelly-like structure. This only is a source of lava that is coming out of the volcano. The material in the upper mantle portion is called the magma. Alright, and when it comes out, it is called lava. So it is difficult. Most people do not understand that what is the difference between magma and lava. It is important to understand that vent, alright, below this volcano we have a asthenosphere which is supporting this coming out, right, of magma. Now when it is below this asthenosphere, it is called magma. When it comes outside, it is called lava. Alright, just remember, when it is in below or the material which is in the upper mantle, just remember mantle, magma. Right? Once it moving out towards the crust or it reaches the surface, it is called lava. The material that reaches the ground includes lava flows, because when from the mantle the magma comes out, it is called lava. Pyroclastic debris. What is pyroclastic debris? It is like boulders, bade patthar, छोटे छोटे पत्थर all of these come out, it is collectively called as pyroclastic debris. Volcanic bombs, ashes, dust, gases like nitrogen, sulfur, minor amount of chlorine, hydrogen, argon. It is also a PYQ, that what all comes out of a volcano. So we have seen that, okay, what is a volcano? It's just a vent or an opening from which gas, ash, molten rock material, lava all come out. Fine. We have already seen that what is the difference between magma and lava. Until unless it is below the surface of earth, it is called magma. Just remember mantle, magma, MM. And when it comes outside the surface, it is called lava. What all now is released? It releases lava, pyroclastic debris, volcanic bomb, बड़े बड़े पत्थर, बहुत बड़े बड़े पत्थर, big particles of stone or big boulders are called volcanic bombs. Ashes, dust, gases like nitrogen, sulfur, minor amount of chlorine, hydrogen and argon. This is all what is released. Now let's move further. Now let's understand that there can be different types of volcanoes, right? Volcano is just like a vent or opening. Now what type of that vent is there, or what type of opening is present, or what type of lava is coming, that also plays an important role in determining the type of volcano that can be formed, right? So first let's understand a shield volcano. Let's see a basic video to just imagine that what is a shield volcano. Alright, so you can just think that okay, ये तो natural है, ये तो normal volcano जैसा ही है. We will understand the basic characteristics of a shield volcano, but just now remember that you can see the lava that is flowing to a large distance, right? Fluid based lava you can see, right? Let's study about the shield volcanoes. So barring the basalt flows, the shield volcanoes are largest of the volcanoes on earth. Alright, so these are second largest volcanoes on earth below the basalt flows. What is this basalt flows? We will see in the video. The Hawaiian volcano are the most famous example. We have seen in the video also, Hawaiian volcano example was mentioned. These volcanoes are mostly made up of basalt, a type of lava which is very fluid when erupted. Alright, so now magma and lava, the difference is clear. Now lava is anything which is coming outside the surface. This lava can also be of two types. Either it can be acidic or either it can be basaltic. When we talk about the basaltic lava बहुत ही fluid होता है. What does it fluid mean? वो बहुत ज़्यादा distance तक spread करेगा. For example, this is the volcano. It will spread till this very huge distance till it will reach. Right, we have seen in the video also. So shield volcano leads to eruption of basaltic lava. And that is why these are big or the large volcanoes which are formed. For this reason, these volcanoes are not steep. What does steep means? Steep means, okay, like this. If the lava that will come out, it solidifies here only, then only steepness will be present. Now it is broad because lava now erupts. Okay, this is volcano. Lava erupts. It reaches to a greater distance. How will it be steep? They become explosive if somehow water gets into the vent. Otherwise, they are characterized by low explosivity. The upcoming lava moves in the form of a mountain and throws out the cone of the top of the vent and develops into a cinder cone. Right. So now what we have seen in the shield volcano is that these are mostly of the characteristic of low explosivity. But these can become explosive when water somehow gets into it. Right. Now think that we have a shield volcano. We are in Hawaii. We have a shield volcano. अचानक से बारिश हो गई, उसकी वेंट में बहुत सारा पानी चला गया. Then only it can explode. Right. And when it explodes with such great energy that this top, from the top which is coming out, this also explodes. Right. And a big cinder cone like this cone is created. We'll see what is cinder cone in the upcoming slides. Second thing that we have to understand, or the second type of volcano that we have to see, is basically the composite volcano, right? Let's see a video. Right. So in this image, you can see that, okay, there are various layers of viscous lava or the pyroclastic ash. Right? Like this lava it freezes here. It solidifies here. Right? Next explosion solidifies here. Next explosion solidifies here. So it is composite volcano is made up of various layers. Right? Let's study it now. So composite volcano. These volcanoes are characterized by eruptions of cooler and more viscous lava than basalt. What is basalt? Basalt is highly liquid or highly fluid, whereas viscous lava do not reach to a higher distances. It solidifies quickly, right? As we have seen that, okay, this is when lava comes out, it solidifies. Another lava comes out, solidifies. Another lava comes out, solidifies. This is how a composite volcano is being formed. These volcanoes often result in explosive eruptions. We have seen that, okay, shield volcanoes are less explosive, only apart from the case where water goes into the vent. However, composite volcanoes are more explosive in nature. Along with lava, large quantities of pyroclastic material and ashes find their way out to the ground. This material accumulates in the vicinity of the vent opening, leading to the formation of flare, and this makes the mount appears as a composite volcano, like various layers of lava solidification are present. We have understood this, and these are the two types of volcanoes. Number one, shield. Number two, composite. Let's see further what are the types of volcanoes. The third one is caldera. Right. These are the most explosive one of the world, of the Earth's volcanoes. Right. Let's see a video to understand that what is the structure of these calderas. Right. So now you can see that there is so much magma chamber or so much source of magma that entire volcanic mountain that which was present here earlier, it collapsed. And then calderas were formed. We have seen an application in the shield volcanoes also. Now let's study about calderas more in detail. They are usually so explosive that when they erupt, they tend to collapse on themselves rather than building any tall structure. The collapsed depression are called calderas. Their explosiveness indicates that magma chamber supplying the lava is not only huge, but it is in close vicinity. As we have seen in the video that, okay, जो उनका magma chamber होता है या फिर जो उन्हें source कर रहा है magma, that is very near to the volcano vent, alright, and that is also very huge. तो फिर जब वॉल्केनो बर्स्ट होगा तो उसमें से इतनी ज़्यादा एनर्जी रिलीज होती है कि वो पूरा स्ट्रक्चर, वॉल्केनो का वो स्ट्रक्चर उस एनर्जी को रिलीज ही नहीं कर पाता अपने से बाहर, एंड इट जस्ट कोलैप्सेस, एंड इट व्हाट इज फाउंड, इट इज फाउंड अ कैल्डेरा स्ट्रक्चर इज फाउंड. लेट्स one time more see the video and we'll understand it better. We can see the structure is present now. It collapsed because of the high amount of energy and magma chamber being in close vicinity and being very strong. Right? We have understood now what is caldera. Right. Let's move further to flood basalt plains. We have seen that, okay, shield volcano is the second largest volcanoes at second number, but the first number is taken by the flood basalt plains. Let's see a video. Right. So you can see that here huge distances lava is flowing. So it's a huge structure of volcano that is formed. For example, Deccan Traps in Maharashtra, India. Let's study flood basalt plain. We have seen the characteristic of basalt right? That it is highly fluid and it goes to a large number of distance. So these volcanoes outpour highly fluid lava that flows for long distances. Some parts of the world are covered by thousands of square kilometers of thick basalt lava flows. These can be a series of flows, like first series of flow, this second series of flow, like this a structure is created, right? The Deccan Traps from India, presently covering most of the Maharashtra plateau, are a large flood basalt province, right? So what is flood basalt plain? When the basalt lava comes out and it spreads to huge long distances, it creates somewhat which is called plain, a plain like structure. Alright, and the last type of volcano that we have to discuss is basically a mid-oceanic ridge. Let's see quickly a animated video to understand the structure. Now you have to understand that we are inside the ocean. Alright, and when this is present, just see that okay, this is somewhat a diversion in the oceanic crust, and from this lava is coming up and flowing. You have to use your imagination in this. Alright, when it is deep inside the ocean and oceanic crust, when divided into two parts, the lava comes out. Let's study about the mid-oceanic ridge volcano now. So this volcano occurs in the oceanic areas. There is a system of mid-oceanic ridge which is more than 70,000 km long that stretches through all the ocean basin. The central portion of this ridge experiences frequent eruption. Now why is it experiencing frequent eruption? Because we have already seen that oceanic crust is only 5 km in thickness. It is so weak that it is very easy for magma to come out in the form of lava. Alright, however, in continental crust like in Himalayas, it is 70 km thick. You'll never experience a volcano in a Himalaya because the crust makes it difficult for the magma to come out. However, oceanic crust is so thin that it becomes easy for the magma to come out. So like this, we have discussed all the types of volcanoes. We have seen the shield volcano, composite volcano, calderas, flood basalt plain and mid-oceanic ridge volcano. Now what we have to understand next is basically what are the different landforms formed by this magma or lava. Fine, let's move on to this section. Right. So we have already seen now that we have to discuss the intrusive landforms. What is this intrusive landforms? We'll now look upon to. So the lava that is released during volcanic eruption on cooling develops into an igneous rocks. We will study in further detail about the rocks. What are the three types of rock, the rock cycle, we'll all study it in detail, right? For now, just remember that igneous rocks are the primary rocks or are the first rocks that are to be formed. Now, how are these formed? When lava comes out, when it solidifies, it becomes hard, and this is what forms the igneous rocks. So the cooling may take place either on reaching the surface or while the lava is still in the crustal portion. Depending upon the location of cooling of lava, igneous rocks are classified as volcanic rocks and plutonic rocks. So when this lava is coming out, now it can solidify either after reaching the surface of Earth or it can solidify below only. Now, if it solidifies below the surface of Earth and it do not reaches the surface, it is called as plutonic rock, that is cooling in the crust. However, when it reaches the surface, it is called a volcanic rock. So the lava that cools within the crustal portion assume different forms. When it is within the crust, it has different forms, and that is what we have to understand in the intrusive landforms, right? To understand better the volcanic and plutonic rocks, let's see a quick video. Right, so we can see that lava, when it cools inside, it is called volcanic. When it cools at it is called plutonic. When it reaches the earth and then it cools, it is called volcanic, right? Now, I hope this is clear to you. So the first landform that is formed by this lava which is cooling inside the earth, or which is a plutonic rock, is batholith. Let's see a video, and it is very, very important to imagine all of these landforms, because then at the later stage it becomes very, very difficult to memorize all of this. So just memorize and use your imaginations as I'm showing you the video. Please just watch the videos again and again. It will stick to your memory, and once it sticks, it becomes easy to remember. Let's see the video for batholith first. Right, so you can see that, okay, this is the big batholith rock which is formed deep inside the earth. And when is this visible? This is visible only when this huge big structure gets eroded by the time, then only this rock becomes visible. Let's study about batholith now. Right, so large body of magmatic material that cools in the deeper layer of the crustal develops in the form of large domes. What is this large domes? That, okay, it's a big body of magma that is cooling deep inside the earth. Like this is crust, alright, magma is coming out. There only a big batholith like structure is solidified in the form of magma. This is called batholith. Alright. They appear on the surface only after the denudation process removes the overlying material. As we have seen in the video, when that big mountain-like structure will get eroded, then only that batholith, or it is also called the underneath bedrock, that will be visible. They cover large areas and at times assume the depth of even several kilometers. These are granitic rocks, and batholith are cooled portion of magma chambers, where from it is the source of magma. When the source of magma or some place close to the source of magma, it solidifies, magma solidifies there. So huge amount of magma will solidify, and what it forms? It forms a batholith. Alright. Just imagine that huge layer of water is present. Suddenly the temperature decreases and it all freezes. This is the batholith of ice, and just consider it in the case of lava, so you will understand and you will be able to imagine. The second thing that we have to understand is a laccolith. The names are very, very confusing, so just try to imagine and recognize them with the images and with the videos. So let's see a video of laccolith now. Alright, so now you can see that it's a dome shaped. It's a dome shaped, right? Which is connected to the magma chamber. This is the source of magma, and it's connected to the source of magma through a pipe like structure. That is laccolith. Fine, let's study. So these are large dome shaped intrusive bodies. We have seen the shape with a level base. We have seen that it has a level base and connected by a pipe like conduit from below. It resembles the surface volcanic domes of composite volcano. Only these are located at the deeper depth. Alright, so these are basically plain surface dome-like structure connected to magma chamber through a pipe-like structure. These are like composite volcano. What is composite volcano? We have already seen that, okay, series of volcanoes, volcanic lava being solidified to form the composite volcano. These are also like composite volcano, but the difference is that these are present at great depth inside the crust. It can be regarded as a localized source of lava that finds its way to the surface, right? So because this also, now the magma chamber or the batholith is at a greater depth and greater distance as compared to laccolith. However, this can play as a source of magma. because it is more nearer to surface. The Karnataka plateau is spotted with the domal hills of granite rock. Most of these now exfoliated are example of laccolith or batholith. So we can see Karnataka plateau has a lot of laccolith or batholith. The next important things that we have to understand is lapolith, phacolith and sills. So just remember that laccolith and lapolith and phacolith, these all are different. Alright, just remember that what is dome shaped, like remember C, D, laco, C and D come together. Alright, so laccolith is like a dome shaped, D for dome. So remember C and D. Now let's understand now lapolith, phacolith and sills. Let's see a video first. I hope you can see in this video the different type of shapes that are formed by phacolith, lapolith and sills. Alright, this is a saucer shaped. What is a saucer? Saucer is like this, in which usually we eat, right? This is a saucer like shape. So what is a saucer like shape? It's a lapolith. Alright, then you can see that here it's a wave like shaped. You can remember phacolith. Alright, syncline and anticline. And then you can see a near horizontal like this. The magma is solidified. It is called a sill. There can be sill or sheet or sill. We will look upon that what is the difference between sheet and a sill. But just now remember what is a saucer like? It's a lapolith. What is a wave like? It's a phacolith. And what is horizontal? It's like a sill, right? Let's move forward. So as and when the lava moves upward, a portion of the same may tend to move in a horizontal direction. Wherever it finds a weak place, it may get rested in different form. In case it develops a saucer-like shape, concave to the sky body, it is called lapolith. We have seen that if it forms a saucer-like shape, what is called? It is called lapolith. A wavy mass of intrusive rock. At times it forms at the base of syncline. Alright, like this. Wave-like structure. What is syncline? Syncline is any type of depression filled with water. Right? Syncline or at the top of anticline. Anticline. So syncline, anticline. Syncline, anticline. What is this? Syncline. This is anticline. In folded igneous rocks, such wavy material have a definite conduit to source beneath in the form of magma chamber, subsequently developed as phacolith. So it has a magma chamber source. These are called what is called phacolith. Fine. So just remember the shape and the name. Just you need to associate it, right? So lapolith is a saucer shaped. Wave shaped is a phacolith, right? And the last one that we have to understand is a sill. So the near horizontal bodies of intrusive igneous rocks are called sills or sheet, depending on the thickness. The thinner ones are called sheet. Sheet you can remember like it is so thin. So any type like this is the rock. If this is horizontal like this solidified magma, it is called sheet. When the thickness is more, it is called a sill. The last intrusive landform that we have to study is basically a dike. So we have till now understand that what is a batholith, what is a lacolith. Lacolith, C, D, dome, right? Then we have to understand what is a lapolith. Lapolith is a saucer shaped. Then we have understand that what is a phacolith. Phacolith is a wave shaped. And then we have seen the sills. Sill is a horizontal thing. The last thing that we have to understand is the dikes. First, let's see a video for dikes and then we'll read it. Alright, so you can just see that okay, sills and dikes are opposite. Sills were solidifying like this. Dikes are vertically solidifying. Sills solidified horizontally. That's the only difference, right? Let's study. So when The lava makes its way through the cracks and fissure developed in the land. It solidifies almost perpendicular to the ground. This is how. This is perpendicular to the ground. This is ground and this is perpendicular, so it solidifies like this inside the crust. It gets cooled in the same place to develop a wall-like structure. Such structure are called dikes. These are commonly present in the intrusive forms in the western Maharashtra area. These are considered to the feeders for eruption that led to the development of Deccan Trap. Alright, so how are Deccan Traps formed? From where they get their magma source? It is from these dikes that they got their magma source. So now we have seen that what are the various types of intrusive landforms that can be formed, and we have already understand these through like certain type of AI animations. This is the best form to study these type of landforms. Otherwise, it becomes very difficult to imagine and visualize them. I hope these visualizations do help you to memorize and remember them for a long period of time. That's it for this chapter, and we'll start with the next chapter in next lecture video. Till then, just revise and just keep visualizing. Keep your memory strong. Keep your imagination strong. That is more important in geography. And keep revising. We'll shortly meet in the next lecture video. Till then, have a good day. Keep revising. Keep learning. Thank you for now.